Okay, we're starting a new book on sound and light. And sound and light both have to deal with these things we call waves. And so this whole first chapter deals with waves and the different parts of waves and the different kinds of waves and how they move and all of the things that can happen with waves. So this first section basically is, what are waves? Well, waves depend on energy. And so in order for a wave to pass through somewhere, it needs energy. So a wave will transfer that energy from place to place. And waves can travel basically through mediums like solid, liquids, and gases. If it's a light wave, which is a type of wave as well, it doesn't even need a medium through which to travel, which is why light can travel through space. But that's a totally different situation, or different discussion for a different time. But for the most part, waves are going to travel through anything. They can travel through liquids, they can travel through solids, they can travel through gases. We're the ones we are most familiar with are the ones that travel through gases, because every time, like right now, you're listening to me speak, you're using sound waves. And sound waves, basically, they travel through the gas of our air, of our atmosphere, so they can get from place to place. And again, it's a form of energy. If you've ever felt your voice box when you're talking, you'll feel those vibrations. Those vibrations are a form of energy, which allows you to talk. And that talking goes, out into the air, and the air goes from one place to another. And because of that, you get sound into your ear. So there's always energy behind the waves. Now, here's a picture down here. We're going to get a little bit more into this as we go along, but this is kind of a quick overview of everything we're going to talk about. There's two different types of waves, transverse and longitudinal. They both move slightly differently, and they move in different ways. And so we'll talk about that as we go along, but this is just kind of an introduction. Okay, as I was saying on the last slide, waves transfer energy. So energy is a big part of this. The cool thing about waves, though, is they transfer this energy of the medium, but they don't necessarily move the medium along with them. So they basically travel through a medium, but they don't move the medium itself. So they're showing here this duck, okay? This duck is sitting right here, and the wave is going through. So it's basically passing through the duck, or underneath or around the duck. And so what's going on here is the wave's moving, and then the duck is basically just kind of staying there, but the wave is moving through him. And then he's on top, and then he's fast, but he's in the same spot where he started from up here. He hasn't moved at all. The wave has moved through him, but it hasn't transferred that medium, that the duck with it, and the water as well. It's just traveling through the water as well. It doesn't take the water with it. It just basically takes the energy through. And that's how waves move. They move as a form of energy. So they're caused by that source of energy and vibrations. Vibrations are a huge part of waves. They either can move back and forth or up and down, and they move the particles of the medium, not necessarily the medium itself. Maybe they cause them to go up and down or back and forth, but whatever. But the medium itself is basically transferred from place to place. Okay, as I was stating earlier, there are two different types of waves. There's transverse waves and there's longitudinal waves, and they're basically classified according to how they move. Transverse waves basically move up and down. If you've ever taken a jump rope and kind of moved it up and down, up and down, up and down, and you see those kind of waves that go through it, that you're creating a transverse wave. And so the direction of the wave itself is forward, but the medium moves up and down compared to that direction of the wave. So when it says transverse waves move the medium at right angles to the direction in which the waves travel, okay, that makes sense because my wave is traveling forward, but I'm moving perpendicular, which means I'm moving straight up, straight down. This is a 90-degree angle to the actual direction of the wave here. And so it basically moves perpendicular to the direction of the wave. That's what we describe transverse waves. The up and down movement is moving forward in general, but it's moving up and down as it's moving forward, which means the particles themselves move at a perpendicular angle compared to the direction of the wave. There are low points and high points to a transverse wave. There's the crest, which is the high points, and then the troughs, which are the low points. So they have high and low points on their transverse waves. Okay, so this is the second type of wave. It's called longitudinal waves, and longitudinal waves move out and in, basically. If you've ever taken an accordion or a slinky and you've moved it in and out using the coils there like that, you are making a transverse wave. A longitudinal wave. It's a longitudinal wave. And they move the medium parallel to the direction of the wave. So here's the direction of the wave, still going forward, and then the springs are going in and out as they move forward. So that same direction of the wave is the same direction in which the wave is moving, or the compressions and rarefactions are moving. So the waves the medium travels parallel to the direction of the wave in this case. There's two different ways these move. When they're closer together, the coils in this case, we call it a compression. When they're further apart, like this right here, we call that a rarefaction. And sound travels this way. So when we have sound traveling anywhere, it travels as a longitudinal wave. So the particles compress and rarefy like an accordion as they travel through the medium of air, or they travel through a solid, or they travel through liquid, whatever it happens to be. They travel in a way where they're moving parallel to the direction of the wave. And those are the different types of waves. There's just two, transverse and longitudinal, and they are basically classified according to how they move. Now, this is a new book. You don't have the book home with you because I did not pass these out. I am putting reading material for every single section on PowerSchool Learning. So there is a PDF file of the section from my book. It's the teacher's edition that you'll be getting. Now, there's also homework that's going to be posted, but you also, when you pick up your next packet, I just didn't know how long it was going to take us to finish that last book and get through everything, and I didn't know how long we'd be out, so I didn't create a packet for this yet. So you're welcome to print this off. You are also welcome to do like write it on a separate sheet of paper, take a picture of it and hand it in, or hand it in with the next hand-in date. These will not be due until our last hand-in date, which is in May sometime, and I will remember exactly what date that is. But you will get a packet at your pickup from April 16th, 17th, or 16th, 17th, or 17th. I don't remember. So it's the middle of April. It's right after Easter, that week after Easter. There will be a pickup, and this will be in the packet. This worksheet that would go with this section. Like I said, you can do it that way, or you can print it up early. Totally up to you. Enjoy!